Hello and welcome back to another video. In this problem, we're asked to find a formula for the described function and state its domain. We have an open rectangular box with volume 2 meters cubed that has a square base, and we're asked to express the surface area of the box as a function of the length of a side of the base. So we have the volume is equal to 2, and that is equal to the length times the width times the height. Now, if we're drawing this right here, we have a square base and a particular height. Okay? If we have a square base, that means that the length and the width are equal. So we can say L is equal to W, and therefore 2 is equal to plugging in the width for the length, so we only have two different variables in this equation. 2 is equal to W times H. And therefore, if we divide by W squared, we can get these cancel. The height is equal to 2 over W squared, 2 over the width squared. So L is equal to W, and H is equal to 2 over W squared. Now we have to express the surface area of the box as a function of the length of the side of a base, which we're going to use W for this because we have everything in terms of W. L is equal to W, W is equal to W, and H is equal to 2 over W squared. So these are our dimensions right here. We're going to use them to find the surface area. So we have 6 sides here. We are going to represent each of them in terms of W. So let's do the top and the bottom are equal to the length times the width. So we have 2 times the length times the width, right? We have the front and the back is equal to the width times the height. So 2 times W times H. And the right and the left are equal to 2 times the length times the height. This is a little complicated. Notice that every combination, LW, WH, LH, all make their way here with the 2 out in front. And now we can turn this, we can call this S of W, right? This function S, the surface area, which takes on W, is equal to 2 times the length, which is equal to W, times W, plus 2 times W times H. H, the height, is equal to 2 over W squared, plus 2, the length is equal to W, so we plug that in, and H is 2 over W squared, so we plug that in again. And now we can have it fully in terms of W, so we have 2 times W is 2W squared. W and one of the W's on the bottom cancel out to get 2 times 2 is 4 over W. And a similar thing here, 2 times 2 over W plus 4 over W. Therefore, S of W, the surface area of the box, as a function of the width, which is one of the sides of the base, is equal to 2W squared plus 4 is 8 over W. This is the surface area. What is the domain? Well, this is a physical box. It has to actually exist in 3-dimensional space, so the width has to be greater than 0. That is the only restriction. It doesn't even matter that we have something in the denominator, since the width can't be equal to 0 anyways. That doesn't even come into effect in determining the domain. This is your function for this particular box. This is the surface area.